Hey guys, I hope you all are doing good. In the last few lectures, we covered sets in detail, right? So we basically covered how sets work, all the definitions, and a lot of questions on sets too. So from this lecture, we will be starting with functions, which is a very important concept in discrete math. Just a quick suggestion, if you don't have a good understanding about sets before this, I would highly suggest that you watch any previous videos that I've uploaded, or you try to find out any videos on internet and try to understand sets in detail, right? If you have a good understanding about sets, then it would be very easy to understand functions. But if not, then it's just highly suggested that you move and do that first. So let's start with the definition of a function, right? According to discrete math, a function from set A to set B is a relation f such that each element in the domain is related to at most one element. So this is the definition in discrete math, but I'll first try to explain what are functions, right? I think we all have covered functions in our high schools. So if you think about it, let's say if I write this function over here, right? So if you consider it, f of x equals x squared plus 1. I think we have all covered in high school functions like this. Basically, what this function is doing is, if you try to understand it in like depth, I input some value x over here, and it results in a value. It squares that value that I input, and it adds a 1 to it, right? Now, why am I doing it? It could be that I can use this value for some other purpose in my like equation or something. But the basic point is that this function is doing some sort of a operation on this value over here, right? So a basic example would be, if I do f of 1, it would result in 1 square plus 1, which is equal to 2, right? So this is just a basic example of a function that we have covered in math. Same way, if you think about it, in coding as well, we write functions. If you have not yet started with functions in coding, then you will probably start it. But basic idea is, in our code, we don't want to write the same code again and again in multiple portions of our code, right? So for example, let's say I want to multiply a certain value with certain value at different points in my code. Then instead of writing that code again and again, I would suggest that I write down a function and then use that function everywhere in my code, right? So in very simple words, and if I have to summarize it, function is sort of a machine. I put in some value and it results in some different value, which I might need for some other purposes, right? That's the basic idea. Now let's try to understand what is the meaning of a function in discrete math. The basic idea of a function remains same, but there are some formalities that we have to understand and some more definitions that we need to understand when it comes to discrete math, right? So a function from set A to set B is a relation f. This word, we will understand relations in detail in the future videos, but for now, just try to understand that it's a word, right? So is a relation f such that each element of the domain is related to at most one element. For now, let's just try to understand the very basics of a function. Basic idea is, I have some set A. Let's say I have set A equal 1, 2, 3, and I have B equal A, B, C. What a function does is, it's basically a relation such that when I put the value from set A into the function, it is going to result some kind of a value in set B over here. So it could be that when I input 1 into the function, it results in A. Maybe if I put 2 into the function, it results in C. Maybe I put 3, it results in B over here. So the basic idea is, I put some value from this set over here and it results some kind of a value in the other set. I'll try to give another example, right? Think about this over here. So this, if you have read about it, or if you have studied it in high school, we have read that there are functions from all real numbers to all real numbers. Basic idea is, this is a set from real numbers, and the resulting value, if you think about it, is also in the set of all real numbers, right? That's the basic idea about what is functions. Now let's try to understand the notation of functions in discrete math. Function from set A to set B is written as f from A to B. If A is an element of A, then value of f at A is written as fa, which is an element of B. just the basic idea is, so if I have, let's say, A equal 1, 2, 3, and I have B equal A, B, C, then a function from A to B, this is the way we denote it, right? So it would basically be from this set to this set over here. And if A is an element of A, then value of f at A is written as f bracket A, which is an element of B. It's kind of just like in math. So for example, when I had written down f x square, sorry, fx equal x square plus 1 over here, just like I wrote down the value x and its resulting value over here, right? So I can write f1 equal 2f2 equal dot dot dot, etc. The basic idea remains the same. Now, if you try to understand this point over here, this basically means the value which is this fa should be a value which is in the set B over here, because that's our function definition, right? We are going from A to B over here. Now, another way to write it down could be we have a function from B to the set A, right? Which basically would mean that I input the value A, B, C into the function, and it results in one of the values in A over here, which is 1, 2, and 3. I hope that makes sense, right? So let's try to understand the definition once again. A function from a set A to a set B is a relation such that each element in the domain is related to at most one element. Now, this word domain over here, I'll give this definition in just a few minutes. But for now, let's try to understand this statement. The domain is related to at most one element. Look, the very important thing to understand in functions in discrete math is that each element from the set A should be related to at most one element. The very simple example is, let's say I have this function over here. So let's say I have function from A to B, and I say that f1 equal A, f2 equal B, f3 equal C, right? So basically one results in A. When I put the value 2 into the function, it results in B. And when I put the value 3 into the function, it results in C. So I think that totally makes sense, right? But so this is a valid function over here. It is a function from set A to set B, and each element in the domain over here, let's try to understand that it would be just set A itself, right? On the left hand side, is related to at most one element. So if you think about it, 1 has only single value in the resulting value, 2 has only one resulting value, and same is with 3. But it would not be a valid function if any of these had multiple different resulting values. So my example is, this is a valid function, but let's say if I had a function from A to B, which is f1 equal A, f1 equal B, f2 equal B, and f3 equal C. This over here would be incorrect. Why? Because if you think about it, the value 1 from the set A has a value A in the function, results in a value A, and the value 1 also results in this value B over here. So the basic point is, a function cannot have a value which results in multiple values. It cannot be more than one. A function should only have one single result when it comes to discrete math. If there's something like this, then this would not be a function. So this is just a very basic thing to understand. It's very important to understand this point over here. So if you look at a function and you figure out that, okay, the values from the set, the left hand side, have any value has multiple values resulting when we put into the function, then it's not a function, right? So just a quick summary about it. Now let's try to understand this through an arrow diagram. So one way, there are different ways to represent functions in sets. So for example, if I have to represent the function over here, right, I can represent a function as 1 comma A, 2 comma B, and 3 comma C. Basically what I'm doing is f equal this set in case of set A and B. What I'm trying to say is 1, when I put into the function, results in value A, 2, putting into the function results in B, and 3, putting into the function results in value C. This is going to be equivalent to writing something like f1 equal A, comma f2 equal B, comma f3 equal C. So both of these are equivalent to each other. So this is just a basic understanding about how you can write it down. There's another way we represent functions, and in my university we covered it in that way. It's basically a UVG representation, but I'll cover it in the later section of this video. For now, let's try to understand that these are two ways we can represent the function, right? So I've set a b, I denote it like this, and then when I have to tell about what are the resulting values of the function, then I can write either is this way or I can write it in this way, right? So I hope that makes sense. Now there's another way we can represent functions, which is through arrow diagrams. Now these are the best ones in my opinion because they're very easy to visualize and easy to understand. So in an arrow diagram, let's say I have a function from A to the set B. Arrow diagram would simply be I represent set AB with these ovals over here. Right? A has 1, 2, and 3, and B has A, B, and C. In order to represent this over here, so F1 equal A, I would simply draw arrow from 1 to A, 2 to B, and 3 to C. I hope that makes sense, right? So what I'm trying to say is it's a function from A to B such that F1 results in A, F2 results in B, and F3 results in C. That's the basic idea. One more thing to understand is it's not necessary that all these values, all three of these values, have a resulting value in the set B. What my point is that it could be the case that maybe 3 does not have a resulting value in set B. Maybe 2 doesn't have it either, and maybe none of them have a resulting value in the set B over here. That would still be a valid function. But the only case where it would not be a valid function is when any of these values, any of the values in the set A, result in multiple values. So if 1 results in A and 1 results in B as well, this would not be a function, right? So if any of the values results in multiple values, it's not a function. That's the only case where you can understand whether it's a function or not a function, right? So I hope you have a good understanding about what is a function, right? The notation and the basic idea how we can represent it in different ways. Now let's move on to the next part. Okay, before I move on, one more point that I need to tell you guys about functions is that while this is not possible, this would be an incorrect function, but the other way around is possible, right? So for example, if I have set A and I have set B, what I can do is, it could be the case that 1 points to A, 2 also points to A, and 3 also points to A. So this is completely justified, right? But in the case that 1 or 2 or 3, any of these elements were pointing to multiple elements in the set B, that would be not a function, right? So now let's move on to the next part. Okay, moving on, let's try to understand these important definitions in functions, right? So having a good understanding about all these definitions is super important when it comes to solving questions on functions, right? So I'm going to cover all these definitions in detail, right? These are very simple definitions and I'll explain each one with an example. First, let's try to understand what are domain and codomain, right? So these two definitions over here. Domain is the set of all inputs and codomain is the set of all potential outputs. In very simple words, if f is a function from A to B, then A is domain, right? Because it is the set of all the inputs, comma B, is the codomain, which is it is the set of all the potential outputs over here. So I hope you have a good understanding about what is the domain and what is the codomain, right? Now let's try to understand what is the image. Before I explain what is image, I'm just going to draw a function over here with an arrow diagram. Right? So let's say I have this function, say f to q p. Okay. So I've drawn this function over here, and let's say it results in this value. Okay. So now let's try to understand the image. What is the meaning of image and what is the meaning of pre-image? The image of an element, now this is a bad definition to be honest, but I'll explain it in simple words. I've written it down just for the sake of it, right? So the image of an element in a set A would be the output of that function for the input. The basic idea is the value, the image of this value over here would be A. The image of 2 would be B. It's kind of like, let's say I'm standing in front of a mirror, and this is a magical mirror, right? I ask it to do anything for me. I ask him to turn me into maybe giant or something like that. I ask him to grow me a mustache or whatever, right? The basic idea is that would be my image. It's kind of like that mirror is acting as a function for me, and over there, it's my image. Now, same way, this function, what it's doing is it's giving an image of 1, which is A. It's giving an image of 2, which is B. Image of 3, which is D. Image of 5 is C. So, right, so for example, image of 1 is A in F P2 Q. So I hope you have a good understanding of what is an image. The pre-image is basically the opposite of an image, right? So basically, the image of 1 is A. Now the pre-image of A is 1 over here. Pre-image of A is 1 and the image of 1 is A, right? So example, pre-image of A is 1. So pre-image of A is 1, pre-image of B is 2, pre-image of 3 is 5, pre-image of D is 3, and that's it, right? 4 does not have an image, E does not have a pre-image. So when we talk about the codomain, we are looking for the pre-image, which is we are looking for a value which it relates to in the set A over here. And when we talk about the image, we are talking about a value in the domain which relates to a value in the codomain, right? So I hope that makes sense. So we have covered domain and codomain. I hope you have a good understanding about both these definitions. Image and pre-image, we have covered this as well. Now let's try to understand these two very important definitions. And I think a lot of questions that we solve or you get in your university are going to be based on having a good understanding about domain of definition and the range, right? Okay. Domain of definition is the subset of all elements in the domain which have a image, right? I'm just going to read out these definitions first for both of them, and then I'll explain how it works. Domain of definition, subset of all elements in the domain which have an image. Subset, the range is the subset of all elements of the codomain which have a pre-image. Now let's try to understand what this means, right? The basic idea is if you look at this set over here, 1 has an image A, 2 has an image B, 3 has an image D, and 5 has an image C over here, right? In this set, in the P set over here, I have total 5 elements. Of those 5 elements, 4 have an image, right? Those 4 elements will be a part of the set called the domain of definition. So, DOD for FP2Q is equal to 1, 2, 3, and 5. These 4 elements are going to be the domain of definition for this specific function over here. Why? Because all of them have a valid resulting value, or I should say image, in the set Q over here. Range is exactly the opposite of this, right? So subset of all elements of the codomain which have a pre-image. So what are the values which have a pre-image in the set? I have A, which has a pre-image 1, B has a pre-image 2, C has a pre-image 5, and D has a pre-image 3, right? So range would be equal to set A, B, C, and D. Right? I hope that makes sense. So trying to summarize it once again, all those values, the set of all those values which have an image are going to be the domain of definition, and the set of all those values in the codomain which have a pre-image would be the range over here, right? So these two are very important definitions. You should have a good understanding about it. Now, the way I've written it down is the way, because these definitions include previous definitions that you need to cover, right? One more thing, if you don't understand words like subsets and maybe like if you don't understand any definitions, it could be possible that we had covered them in sets. For example, subsets is a definition that we covered in sets. So if that's the case, try to understand these definitions before, like cover them, try to understand them, and then move on to this video, right? Okay. So now let's move on to the next topic. Okay. Now let's try to understand different ways we can represent functions, right? I've already covered 2 ways we can represent functions. So there could be, we can represent it as set of ordered pairs. For example, F1A, tuple 1A, tuple 2B, and tuple 3C. The basic idea is, if I turn this into an arrow diagram, then this is what it would mean, right? 1 points to A, 2 points to B, and 3 points to C, right? So I hope you have a good understanding about the set of ordered pair representation and the arrow diagram representation, right? Now, there are 2 other ways we can represent it. First, let's try to understand the table representation. So the table representation would simply be, I have, let's say, A, and I can say this F A, and I can form a table like this. So for example, let's say X and F of X. So I have 1 resulting value is A, 2 resulting value is B, 3 resulting value is C. So this is the basic table representation of a function, right? So I hope you have a good understanding about what is a table. So this is the table representation. This is the arrow diagram representation, and this is the ordered pair representation. Now let's try to finally understand the last definition, which is the UVG tuple representation. Now this is the representation that I covered in my university, right? So this is a very simple definition once again. Basically, what this means is, in UVG, this is the set UVG. So these 3 are basically the sets. U over here is the domain, right? V is the codomain, and G is the graph. Now I'll try to explain each one. This is basically a very simple representation. What the idea is, in the tuple representation, U is going to be the domain. So I write down the entire domain in a set. V is the codomain. So I write down the codomain in the set. And graph is basically this entire set over here, right? So basically, this is the set with the tuples of where the element points. So I'll give an example of how I can represent this function with this representation. So this would be equal to, I have the set A, which is 1, 2, 3, comma set B, which is A, B, C. Finally, I have the graph over here, which is simply going to be this entire set. So it's 1 comma A, 2 comma B, 3 comma C, and then finally this is going to be a tuple. So this is U, this is V, and this over here is the graph over here, right? So this is the basic representation. Now you should have a good understanding about all these representations. When you see a representation, you should be able to convert it into any other form. So if I give you the arrow diagram representation, you should be able to convert it into the UVG form or into the ordered pair form, the arrow diagram, or the table, right? The reason I'm saying this is in any of the questions, you could be given any form, right? Um, if you have been specifically covered only a few representations, then that's good. But in a general case, you should just understand and know how I can convert this definition into an arrow diagram or the other way around, right? So I think that's all for this video. Now I will be giving a bunch of questions, some tough ones, and I hope you guys can solve it. I'll solve them towards the end. Okay, so I hope you guys have solved all these questions. These are not very tough questions, to be honest. These are just like the most simplest ones. But don't worry, in the next lectures we will be covering some very difficult questions as well, right? So now let's try to solve all these questions one by one. Starting with the question is function or not. So consider the function f. Now we have been given the basically the set representation, I should say, f, which is tuple 1 to a, 2 to b, and 1 to c. Is this a valid function from set A, which contains two elements, 1 and 2, to set B, which is A, B, C? So let's try to take a look at the function. 1 has an image A, 2 has an image B, and 1 again has an image C. Now this is a problem over here, right? f1 equal A and f1 equal C as well. But if you remember the definition of a function, each element from the domain should have at most one image. That's the simple definition, right? But over here, one has two different images, and this would not be a valid function. So the answer is no, right? Moving on. Given the sets A, 1, 2, 3, and B, x, y, z, and F equal 1x, 2y, and 3y, draw an arrow diagram and answer the following questions. So I'm going to draw an arrow diagram for it. Let's say I have A, B over here, 1, 2, 3, x, y, z. 1 points to x, 2 points to y, and 3 points to y again. Remember, this is a valid function because each element in the domain is pointing to a single value, right? If any of these values were pointing to multiple values in the codomain, that would be an invalid function, right? So just a quick memorization. So we have done this task over here. We have drawn an arrow diagram, right? I'll just draw these oval shapes around it too. What is the domain? Now, domain is simply going to be this entire set A, right? The set of all the inputs. So what is the range? Domain is equal to 1, 2, 3. What is the range? Now, if you remember range, all those values in the codomain which have a pre-image are basically the set of range, right? So if you look at it, x has a pre-image 1, y has a pre-image 2, but z does not have a pre-image. So the only elements in the range would be x and y. So the range would be x, comma, y. Last question is, what is the pre-image of y, right? What is the pre-image once again? It's basically the opposite of an image, right? So the value of like the opposite of the function. Over here, y has two pre-images, right? Pre-images 2 and 3. So I hope you were able to solve these two questions. Moving on, let's try to understand question number 3. Given a function, now if you take a look at this, we have been given the UVG representation, right? So this is U, this is V, and this is the graph. U means the domain, V means the codomain, the graph basically means the function values. So basically, let's try to solve this question. Write this in the set of ordered pairs form. Ordered pairs form would simply be f equal 1a, 2a, and 3b. Okay, this is the set form. What is the arrow diagram over here? So I'm just going to draw it at the very top. Let's say I have the set A, or I can say P, 1, 2, 3, Q, which is A, B, and we have been given the function value. So 1 points to A, 2 points to A, and 3 points to B, right? So this is the arrow diagram representation at the very top, right? Now, so this is just a question that for you guys to understand the different representations we have. Last question, can a function's domain be equal to the domain of definition? Important question once again. What is the domain of definition? All those elements that have the set of all the elements which have an image, right? Domain is the set of all the inputs. So do you think the domain could be equal to the domain of definition or not? The simple answer is yes. And this would be in the case, now think about it, right? Let's say a function from A to B. If you look at it, all the values in the domain 1, 2, and 3 have an image, right? So 1 has an image x, 2 has an image y, and 3 has an image y. All these values have an image, so all these values would also be in the domain of definition. So what that means is domain is 1, 2, 3, and domain of definition for this example over here would also be 1, 2, 3. So in this example, domain is equal to DOD. So the basic answer to this question would be yes. Right? So I hope you were able to solve all these questions. These are very easy ones. In the next video, we will move on to some more complex topics and functions. Right? So stay prepared and thank you so much.